So, good morning, dear students. Myself, Dr. Lingaraju, Government First Degree College, Tumkur. It is belongs to Tumkur University. So, today we'll discuss in fluids session number 27. That is variation of viscosity of liquid with temperature. So, last class we discussed using a Pauli's experiment, the temperature. Sorry, without just we are going to discuss the concept is coefficient of viscosity of water. So now we will discuss very interesting point, variation of viscosity of a liquid with temperature. That is here we know. Usually, if the temperature will be varies, the viscosity of the liquid is also varies. For that reason only, so the viscous different kinds of liquids we are using in different variations, in different conditions, in different places. If a lower viscosity of a liquid maintain at a particular temperature, its viscosity will be going to decreases. So it means it does not work as like a room temperature. The viscous force does not work as like a room temperature. But higher intensity, higher viscous liquid, say grease, coal tar, so they can maintain up to some range of temperatures around 100 numbers, more than 100 temperature, 100 degrees Celsius. So it maintains sustain. Like that, what here we are going to know about this concept means, if the liquid is going to vary the different viscosity properties with respect to the temperatures. That's why how it is going to varies. How here we are going to varies. So that concept here today we will discuss. That is variation of viscosity of a liquid with respect to the temperatures. So here this concept here we are going to discuss through a BSc chapter in physics subject. This syllabus will be comes under a F4 BSc concept. So here we know the effect of liquid with respect to the temperature. That is also we can categorize a factors affecting viscosities. Factors affecting viscosities. So that one is the coefficient of viscosity. The coefficient of viscosity of a liquid decreases. The coefficient of viscosity of a liquid will be decreases rapidly with increasing of temperatures. That is already in the previous class we discussed. The viscosity of water at 80 degrees Celsius is only 1/3 of its value at 10 degrees Celsius. You see how? The viscosity of water at 80 degrees Celsius is only 1/3 of its value at 10 degrees Celsius. You see how the viscous force will be going to varies. Many empirical formulas were suggested for variation of viscosities with temperatures. The earliest empirical formula representing variation of viscosity with respect to temperature, which claim a fair of degree of accuracy, was suggested by a Sloty scientist name. What is the name? Sloty. The formula is given by Sloty, that is eta is equal to A by A plus Bt to the power of N. So here the coefficient of viscosity of a liquid at a temperature T. Here what the two constants they are using A and B and eta R depends upon the nature of the liquid. Nature of the liquid. So this is if you know this one coefficient of viscosity of a large number of liquids at different temperatures, we can conclude it or we can calculate it. So knowing this one, we'll discuss the viscosities. The viscosity of a fluid is due to two contributing factors. Viscosity of fluid two important contributors, important factors, namely the cohesion between the fluid molecules and the transfer of momentum between the molecules. The cohesion inside the strength of our liquid. Cohesion between the fluids of molecules. Each molecules cohesion is name is factor and transfer of momentum between the molecules. Momentum, how much they are having it, mass into velocity. So how much they are having it. Depends upon these two factors, the liquid, how much viscosity they have it. That is depends. In the case of gases, different. The interface between the molecules is large, and so the intermolecular cohesion is negligible. So far, both in the case of liquids, the molecules are very close to each other and accordingly a large cohesion exists. You see, whatever the liquid we taken, knowing the two kinds of a force existing inside the viscous, so internal atoms interactions of two bodies and how much they have momentum. Knowing these two cases, the case of a liquid, the molecules are very close to each other and accordingly the large cohesion exists. Hence, in liquids, the viscosity is mainly due to intermolecular cohesions. Important the viscosity is mainly due to intermolecular cohesions. While in gases, viscosity is mainly due to molecular momentum transfer. Molecular momentum transfer on gases. In intermolecular cohesion, force decreases with the rise of temperature. The intermolecular cohesive force decreases with the rise of temperature, and hence, with the increasing of the temperature, the increasing of temperature, the viscosity of the liquid will be decreases. So we know it from this kind of a viscous force materials. Knowing this concept, Pauli's explained one relations. That is, so Pauli shows the dependence of viscosity of a liquid on temperatures. So eta T, that is equal to eta naught 1 by 1 plus alpha T plus beta T square. Eta T is equal to viscosity of liquid at T degrees Celsius in poise. So viscosity of liquid at 4 degrees Celsius in poise. Alpha and beta are constant values. So knowing this one, knowing this concept, eta is equal to, if calculating the values alpha and beta, here it is hitting 1.79 into the minus 3 poise. But this formula varies from experimental results. The formula is modified as eta T is equal to A by 1 plus Bt to the power of C. Here A, B and C are remains constants. Knowing this above formula is slightly better than the previous formula, but it fails to explain the viscosity of a certain classes of a liquid like oils or any mixtures of chemical compounds. Andre, scientist's name, he suggested another formula which is found to be most satisfactory in explaining the variation of viscosities of liquid with respect to temperature. The formula for that Andres relation is eta v to the power of 1 by 2 is equal to a c to the c by a to the power of c by vt. So knowing this concept, here V is the specific volume of a liquid, 7 is the absolute temperature fixed for the particular viscous force. The formula is applicable to water as well as some tertiary alcohols. So it means lower viscous materials. This relation is depends on lower viscous materials. So in the case of gas, as mentioned earlier, the intermolecular cohesion being negligible, the viscosity depends mainly on transfer of molecular momentum in a direction at right angles. To the direction of the motions. So now here, as the temperature increases, the molecular agitation increases. It is correct. The temperature increases, the molecular, you see, if it is there like the agitation means it is going to increase its intermolecular distances. That is nothing but agitations. The temperature increases, the molecular agitation increases. That is, there will be a large moment transfer. There is a large moment transfer, and hence the viscosity increases. Almond gave the following expression for the viscosity of a gas. Eta is equal to 1.715 10 to the power minus 4 into 1 plus 0.00275 t minus 3.4 to the power minus 17 t square of pies. So knowing these relations, so in liquids, viscous force are caused by molecules exerting attractive forces on each other across layers of flow. Liquid viscous forces are caused by molecules exerting attractive forces on each other across layers of flow. Next is increasing the temperature results in decrease in viscosity, because a larger temperature means particles have greater thermal energy and are more easily able to overcome the attractive forces binding them together. Next, the everyday example of this viscosity decreases to cooking oil, moving more fluidity in a hot firing pan than in a cold one. So like that here we are going to discuss. So once again I will repeat this concept from the beginning. So here I want to calculate the viscosity of the material will be going to changes to affecting the temperatures. The coefficient of viscosity of a liquid decreases usually with increasing the temperature. The viscosity of water at 80 degree Celsius is only one third of its value at 10 degrees Celsius. Many empirical formulas were suggested that for a variation of viscosity with respect to temperature, the earliest empirical formula representing variations explained by a Sloty. He explained which could claim a fair degree of accuracy. That is given by neta n neta is equal to a by 1 plus bt to the power of n. So here a, b and n are remains constants. But in the case of liquid, the molecules are very close to each other. Accordingly, a large cohesion exists. Yavaga room temperature. But hence in a liquid, the viscosity is mainly due to the intermolecular cohesions, while the gas viscosity is mainly due to molecular momentum transfer. So here if we apply the heat energy towards the body, so the intermolecular atoms, what they are having a distances, it is going to increase. Increase, it means they are going to disturb. It is going to increase the distance rapidly. So it leads the variation of viscosity of a particular any kind of a liquids. The intermolecular cohesive force decreases with rise the temperature, and hence with the increasing of temperature the viscosity of a liquid will be decreases. So that is the concept what here we are going to discuss. If the temperature will be applied knowing these relations. So all these concepts will be I have referred in a Sundararajan textbook. Sir is explained excellent phenomenon through a United Publishers books. Name of the book is College Physics. And also one more another very good author, that is Subramaniam sir. Sir has written through a textbook of optics published in a Chand publications. Remaining 4 different kinds of books are published by our Tumkur University prescribed textbook from the Tumkur University different colleges, affiliated college lecturers. I gone through all these concepts, I referred and I collected the notes, and also I discussed through this concept, that is the temperature dependence on the a particular viscosities. Majorly here we know, usually we can directly say any kind of a liquid, if the temperature will be applied, the viscosity will be going to decreases. Knowing this important phenomenon, so what here we are going to learn? Usually we know the liquids having a different viscosities. There we are going to utilize in some various applications. For example, in a larger machines in factories, automobiles, vehicles, in home applications. So for all, if the automobiles or machines, after applying some viscosity liquid, if the temperature rises, means the viscosity is going to decreases. So far, whatever the viscous prime applications we are expecting from the particular liquid, it is going to fail. So far, we have to choose what kind of a viscous forced liquid we require. Already we made it a 2 different kinds of a viscous liquids, lower viscous materials and also a higher viscous materials. So lower viscous materials means they having a lower viscosity of a force, say water, kerosene. So they are having a very less proportionality of that order. They have to work it. If you apply the temperature, means once again the viscosity will going to lose itself. 1/3 of the viscosity is going to decreases. But instead of that, if you use higher viscosity materials, say coal tar, grease, etc. So they will be a persist up to a certain range of temperatures. Using that particular type of viscous force materials, we have to choose it. So it's about the temperature of a viscosities. Thank you and all.